Does the solid concrete beneath your shoes feel permanent and unmoving? It is a convincing illusion. Thousands of miles down, a world exists that defies every rule of physics you know. If you traveled through the crust and past the boiling magma, you would eventually reach a place where the pressure is 3.5 million times higher than the weight of the air at the beach. A giant, glowing sphere of metal the size of the moon sits in this crushing darkness. This is the Earth's inner core. For decades, the consensus held that it was a silent, heavy ball of iron. A landmark study published in the journal Nature Geoscience in 2023 revealed that this inner core is a solid crystal spinning at its own speed, entirely independent of the rest of the planet. Recently, it slowed down, stopped, and now appears to be drifting in the opposite direction. The ground you walk on is a thin shell floating over a violent, shifting interior. Richard Dixon Oldham first realized in 1906 that the Earth was not solid all the way through, by tracking the vibrations of earthquakes as they rippled through the planet. He noticed something was blocking them. This was the first hint of a hidden world. A few years later, Benoit Gutenberg calculated that this mysterious core started about 1,800 miles down. The real breakthrough arrived in 1936 from Danish scientist Inge Lehmann. She looked at seismic data and realized there were two cores. There was a liquid outer layer and a solid heart. We are living on top of a giant, floating metallic engine that is hotter than the surface of the sun. Think about a compass needle. It points north because the Earth is a giant magnet, and that magnetism comes from the core. Because the core floats inside a sea of liquid metal, it can move at a different pace than the mountains and oceans above it. In 1996, researchers Xiaodong Song and Paul Richards published evidence that the inner core was winning the race. It was spinning slightly faster than the rest of the Earth. They called this superrotation. It was as if the very center of our world was a passenger on a train who decided to start walking toward the front car. It was moving and changing right under our feet without anyone feeling a thing. How can something stay solid when it is over 9,000 degrees Fahrenheit? Heat typically turns metal into liquid, a process visible in a blacksmith's forge or a steel mill. The center of the Earth is different. The weight of all the oceans, the continents, and the mantle presses down so hard that the atoms of iron are forced together. They cannot melt, instead they lock into a rigid, repeating pattern. It is a crystal. This moon-sized ball of crystalline iron is suspended in a liquid outer core, disconnected from the rocky crust we call home. It is a planet within a planet, governed by forces that seem to break the laws of nature. The 2023 study by researchers at Peking University sent shockwaves through the scientific community. They analyzed decades of earthquake records and found that the inner core's lead in the race had vanished. Around the year 2009, the inner core seemed to come to a total halt relative to the surface. Since then, it has been moving slightly slower than the crust, which makes it look like it is rotating backward from our perspective. Imagine you are driving on a highway and a car next to you slowly brakes. Even though you are both moving forward, the other car appears to be sliding backward away from you. That is what is happening to the center of our world right now. This is not just a curiosity for geologists. The rotation of the core creates our magnetic field, a giant invisible shield that protects us from deadly solar radiation. Without it, the atmosphere would be stripped away and life would end. When the core changes its stance, everything else can change too. Scientists believe these shifts in rotation happen in cycles lasting about 60 to 70 years. We might be in the middle of a massive global reset that happens deep underground, far beyond the reach of any drill or camera. It is a rhythmic heartbeat of the planet that we are only just beginning to hear. To put this scale in perspective, the inner core contains about 1/3 of the Earth's total mass, but takes up less than 1% of its volume. It is incredibly dense and powerful. In 2002, Harvard researchers Miyake Ishii and Adam Dziewonski found evidence that there might even be an inner core. This is a smaller, 300-mile-wide ball of iron at the very center with a different crystal structure. It is like a set of Russian nesting dolls made of white-hot metal. Each layer has its own rules and its own history, stretching back billions of years to the birth of the solar system. We often look up at the stars and wonder about distant galaxies, but we are standing on top of one of the greatest mysteries in the universe. We have sent probes to the edge of the solar system, yet we have never traveled deeper than 7 miles into our own ground. The deepest hole ever dug, the Kola superdeep borehole in Russia, is a mere scratch on the skin of the Earth. Everything we know about the core comes from listening to the echoes of the planet. We track the way sound waves bounce and bend as they hit that central crystal heart. We are listening to a giant, metallic bell ringing in the dark. The realization that the core is slowing down changes how we see our place in the cosmos. It reminds us that the Earth is not a static rock, but a living, breathing machine. The length of a day on Earth actually changes by fractions of a millisecond because of these shifts in the core. The magnetic poles drift because of the sloshing of the liquid metal. Even the sea levels might be slightly affected by the gravitational tug of the inner core as it wobbles. We are tethered to a giant, spinning crystal that we can never see, touch, or reach. Next time you look at the horizon, remember that the ground isn't just dirt and stone. Beneath you, a moon-sized crystal of iron is currently changing direction, sliding through a sea of liquid fire. It is the engine of our world, and it is governed by a clock we are only just starting to read. While we know the core is shifting, scientists still can't fully explain why this cycle happens every 7 decades. The very shield protecting your life depends on a mystery we are still trying to solve. How can a planet nearly 13,000 kilometers wide feel so fragile when we only inhabit its thinnest outer skin? If the Earth were an apple, our entire world, the oceans, the atmosphere, and every mountain peak would be thinner than the peel. We have sent probes to the edge of the solar system and mapped distant galaxies, yet we have barely scratched the surface of our own home. The Kola superdeep borehole in Russia, the deepest hole ever dug, reached just 12 kilometers down before the heat became unbearable. That is less than 0.1% of the way to the center. For a long time, the world beneath our feet remained a total mystery. A dark void we assumed was simply solid rock. In 1906, Richard Dixon Oldham noticed something strange while working for the Geological Survey of India. He wasn't looking at rocks, but at the way the Earth shakes. When a massive earthquake strikes, it sends vibrations rippling through the entire planet like a bell being struck by a hammer. These seismic waves allowed Oldham to discover that vibrations didn't travel in straight lines or at a constant speed. Instead, they seemed to hit a wall deep inside the Earth and slow down or bounce away. He realized that the Earth wasn't a uniform ball of stone and possessed a distinct core. In 1913, Benno Gutenberg at the California Institute of Technology used this wave data to calculate exactly where this boundary began. He found it sat about 900 kilometers beneath the surface. This massive discovery left scientists with a frustrating problem because they could see the shadow of the core, but they couldn't see what was inside it. For decades, the leading theory suggested the core was one giant ball of liquid metal. In 1936, a Danish scientist named Inge Lehmann noticed something that didn't fit. She was studying records of a large earthquake near New Zealand and saw that some waves were appearing in places they shouldn't be able to reach if the core were entirely liquid. She proposed that inside the liquid outer core, there was a second, smaller ball that was completely solid. It was a heart of solid iron and nickel, the size of the moon, suspended in a sea of molten fire. This inner core is under so much pressure, millions of times the pressure at sea level, that the atoms are forced together into a solid crystal, even though the temperature is hotter than the surface of the sun. To understand how we study something we can never touch, think of a doctor using an ultrasound to see a baby inside a womb. The doctor sends sound waves into the body and listens to how they bounce back off different tissues. Geologists do the exact same thing with the Earth. By timing how long it takes for earthquake waves to travel from a fault line in Alaska to a sensor in Antarctica, they can map the density of the layers they pass through. In 1981, Adam Dziewonski and Don Anderson used this method to create the first standard model of the Earth's interior. They proved that the Earth is like a giant machine with moving parts where each layer slides against the other. In 1996, Xiaodong Song and Paul Richards at Columbia University noticed something that seemed impossible. The inner core wasn't just sitting there, but was moving at a different speed than the rest of the planet. This is where the story takes a turn into the truly bizarre. Because the inner core is floating in a liquid outer layer, it isn't physically locked to the crust we live on. It is being tugged by the Earth's massive magnetic field and the pull of gravity. Song and Richards discovered that the inner core was rotating slightly faster than the mantle and the crust. Imagine you are sitting in a spinning office chair, but your heart is spinning even faster than your ribs. For years, this superrotation was the gold standard of geology. In early 2023, a study published in Nature Geoscience looked at decades of seismic data and found that this rotation had suddenly done something nobody expected. It had slowed down. The researchers analyzed earthquake records from as far back as the 1960s. They found that around 2009, the inner core's rotation seemed to pause relative to the surface. It wasn't that the core stopped spinning entirely, as everything in space is spinning, but it was now perfectly synced with the crust. Then it started to lag behind. The data suggests that the inner core might actually be beginning to rotate in the opposite direction relative to us. This isn't a global catastrophe, but it is a massive shift in the mechanics of our planet. It suggests that the center of the Earth operates on a cycle, swinging back and forth like a giant, slow-motion pendulum every 6 or 7 decades. Why does a solid ball of iron 5,000 kilometers below us change its rhythm? The answer lies in the invisible forces that keep us alive. The liquid outer core is a churning ocean of molten iron, and its movement creates the Earth's magnetic field. This field acts like a shield, protecting us from deadly solar radiation. But the inner core is also caught in a tug-of-war. The magnetic field pulls it one way, while the immense gravity of the rocky mantle above pulls it another. When these forces shift, the core speeds up or slows down. It is a delicate balance of physics occurring in a place where the temperature reaches 6,000 degrees Celsius and the weight of the entire world presses down. But here is where it gets strange. If the core is changing its rotation, does that mean our days are changing too? The answer is yes, but in a way that is almost impossible to feel. Because the core and the mantle are linked by gravity, a change in the core's speed can actually shift the rotation of the entire planet. Scientists have found that these cycles in the core's movement match up with tiny fluctuations in the length of a day, measured in fractions of a millisecond. It is a reminder that the ground beneath us is not a static platform. We are riding on top of a complex, shifting engine that is constantly adjusting its own speed. Even with our best technology, we are still finding new layers to this engine. In 2002, Maeki Ishii and Adam Dziewonski at Harvard proposed that there might be an innermost inner core. Deep inside that solid ball of iron, they believe there is another distinct zone, about 650 kilometers wide, where the iron crystals are packed in a different orientation. It is like a nesting doll of geological mysteries. Each time we think we have mapped the center, we find a new boundary, a new speed, or a new physical state that challenges our understanding of how planets are built. We are walking on a world that is still hiding its most basic secrets. The movement of the core isn't just a curiosity for geologists. It is the reason we have an atmosphere, the reason we have North and South poles, and the reason our planet hasn't turned into a cold, dead rock like Mars. The fact that the center of our world can change its rotation without us even feeling it shows just how much is happening in the dark spaces we can never reach. If the very center of the Earth is shifting, What does that mean for the magnetic shield that protects every living thing on the surface? Why would the vibrations of a massive earthquake arrive late on the other side of the planet? In 1906, Richard Dixon Oldham sat in his office at the Geological Survey of India, surrounded by jagged lines on paper that suggested an impossible delay. These earthquake recordings from across the globe revealed a secret. Oldham realized the seismic waves were hitting a dense obstacle deep inside the Earth. In his paper, The Constitution of the Interior of the Earth, he proved that we do not live on a solid rock, but on top of a giant, hidden ball. 7 years later, Beno Gutenberg at Caltech refined this discovery by calculating that this boundary sits exactly 900 kilometers beneath our feet. This distance is the span from New York City to Denver, but pointed straight down into the dark. For decades, the scientific community viewed this core as a simple lake of liquid fire. In 1936, a Danish researcher named Inge Lehmann noticed something even stranger while studying seismic waves from a 1929 earthquake near New Zealand. She saw weak signals reflecting off a structure even deeper than the liquid layer. Lehmann realized there was a solid heart inside the fluid. This inner core is a ball of iron and nickel, 220 kilometers thick, nearly the size of the moon. It is a place of impossible physics where the temperature screams at 200 degrees Celsius, nearly as hot as the surface of the sun. Normally, iron would turn into a thin gas at that heat, but the weight of the entire world presses down with 6 million times the pressure of our atmosphere. This crushing force squeezes the atoms so tightly they cannot melt, locking them into a white hot, solid crystal. This solid crystal heart keeps you alive. As the Earth cools over billions of years, the liquid outer core freezes onto the solid inner core, a process that releases a staggering amount of heat. This energy creates massive, swirling currents in the liquid metal above it, much like a pot of boiling water. Because that liquid metal is mostly iron and is constantly moving, it acts as a giant electrical generator. Scientists call this the geodynamo. In 1952, Francis Birch from Harvard University argued that this iron engine is the source of our planet's magnetic field. This field acts as an invisible shield, wrapping around the Earth and stretching far into space to deflect the violent solar wind and radiation. Without this engine in the basement of our world, our atmosphere would be stripped away, leaving Earth as a dry, dead husk like Mars. This engine is not a steady or unchanging machine. In 1981, Adam Dziewonski and Don Anderson published the preliminary reference Earth model, which became the global map for our planet's interior. It showed the core as the most dynamic part of our world, but it also revealed mysteries we still haven't solved. For example, the inner core isn't a perfect, smooth sphere. In 2002, Miyake Ishii and Dziewonski published evidence in the Proceedings of the National Academy of Sciences suggesting there is an innermost inner core. This is a 600-kilometer wide seed at the very center that has a different crystal structure than the rest. We are standing on top of a Russian nesting doll of ancient geological history, a planet within a planet. The most shocking discovery came in 1996, when Xiaodong Song and Paul Richards published a paper in the journal Nature. They analyzed decades of earthquake data and found that the inner core was spinning at a different speed than the rest of the planet. It was rotating faster, completing a full extra turn every few hundred years. This is possible because the inner core floats in a sea of liquid metal, disconnected from the rocky mantle above it. However, the data changed recently. A 2023 study in Nature Geoscience found that this rotation has not only slowed down, but it might have paused entirely. The core appears to be changing its rhythm compared to the surface, and some researchers believe it might even be starting to rotate in the opposite direction. This shift sounds like the plot of a disaster movie, but for the scientists watching the data, it is a puzzle of planetary mechanics. When the core changes its spin, it can slightly tug on the Earth's magnetic field and even alter the length of a day by a fraction of a millisecond. Imagine a mass of solid iron larger than Pluto, shifting its momentum thousands of miles beneath your bed. To visualize the scale, picture a ball of metal weighing billions of trillions of tons, spinning in a bath of liquid fire to generate a force field that protects every living thing on the surface. That ball has just decided to change its gears. We are only just beginning to understand how this internal heartbeat regulates the world we see above. Scientists still can't fully explain why this rotation cycle happens. The leading theory describes a delicate tug-of-war between two massive forces. On one side, the magnetic field generated in the outer core tries to spin the inner core faster. On the other side, the immense gravitational pull of the rocky mantle above tries to lock it in place. This creates a rhythmic oscillation, a slow-motion wobble that takes decades to complete. Every time the core shifts, it sends ripples through the systems that make Earth habitable. It affects how heat moves through the planet and how the magnetic North Pole drifts across the Arctic. The ground feels still, but the engine beneath us is constantly adjusting and turning. This matters for our future because while the core protects us, it is also slowly dying. Eventually, billions of years from now, the entire core will freeze solid. When the liquid outer core stops churning, the magnetic field will vanish. The sun's radiation will hit the surface with full force, and the oceans will evaporate into space. This is the fate that Frank Moore-Cross and other experts believe befell Mars long ago. Our neighbor planet once had a liquid core and a magnetic field, but because Mars is smaller, it cooled down faster, its engine seized up, and its atmosphere blew away. The only reason we are here today to ask these questions is because our engine is still hot, still liquid and still spinning. Understanding the core is about tracking the life support system of the entire human race. We have spent trillions of dollars exploring the stars and mapping distant galaxies, yet we have never sent a probe more than 12 kilometers into our own planet. We know more about the composition of stars millions of light years away than we do about the rock directly beneath the soles of our shoes. Every time a major earthquake happens, it acts like a giant ultrasound, giving us a fleeting glimpse of that white-hot crystal heart. Each new study, like the 2023 rotation report, reminds us that the Earth is not a static stage. It is a living, breathing machine with a complex internal rhythm we are only just starting to hear. The question that researchers are now racing to answer is how these deep shifts affect the surface in the long term. If the core has indeed slowed down or reversed its spin, what does that mean for the stability of our magnetic shield over the next century? We know that the magnetic poles have flipped many times in Earth's history, where north becomes south and south becomes north. Could these changes in the core's rotation be the first sign of another global flip? As we look at the compasses in our hands and the satellites in our sky, we have to wonder how much of our modern world depends on the mysterious, shifting movements of a giant iron crystal we can never see. Could a ball of iron the size of Pluto change its rhythm without us ever feeling a vibration? The discovery that the Earth's inner core spins independently was already enough to rewrite every geology textbook in existence, transforming our understanding of the planet from a static rock into a complex machine with moving parts. In January 2023, Yi Yang and Xiaodong Song of Peking University published a study in Nature Geoscience that made previous breakthroughs look like a footnote. They tracked how that rotation changes over decades. By analyzing seismic waves from repeated earthquakes that traveled through the core between 1964 and 2021, the researchers noticed a pattern that seemed physically impossible. The inner core appeared to be slowing down. This wasn't a minor dip in speed. Data suggested that around 2009, the inner core's rotation relative to the Earth's surface nearly ground to a halt. The core didn't stop moving in space, but it stopped outpacing the crust we live on. Imagine a faster runner on an indoor track who suddenly slows to the exact pace of the person walking in the lane next to them. For a few years, the two were perfectly synced. Then, the data showed something even more jarring as the core began to slip backward. It started rotating in the opposite direction relative to the surface. Scientists realized they were witnessing a massive planetary heartbeat. The 2023 study proposes that this is part of a 70-year cycle. Imagine a heavy pendulum twisting back and forth deep beneath your feet. Based on the 1964 to 2021 seismic records, the core seems to spend about 35 years spinning slightly faster than the crust, followed by a brief pause, and then 35 years spinning slightly slower. This rhythmic pulse has been happening for billions of years, hidden 4,000 miles below the clouds and the dirt. We are just now finding the tools sensitive enough to hear it. The leading theory for why this happens involves a violent tug-of-war between two of the most powerful forces in nature. On one side, the Earth's magnetic field acts like a motor. This field is generated by the swirling liquid iron in the outer core and pushes the solid inner core to spin faster. On the other side, gravity pulls back. The Earth's mantle is not perfectly smooth and contains massive, heavy structures that exert a gravitational pull on the inner core to keep it from spinning too fast. This constant pushing and pulling creates the 70-year oscillation. This discovery moves the conversation from abstract physics to something that affects your daily life. Because the core is so massive, its shifting rotation changes the momentum of the entire planet. When the core slows down or speeds up, the Earth itself has to compensate. This results in a measurable change in the length of a day. The shift is measured in milliseconds, tiny fractions of a second that are invisible to a human being but massive for a planet. The very definition of time on Earth is being dictated by a swaying crystal ball thousands of miles underground. The implications ripple even further than the clocks on our walls. Researchers are now investigating whether this 70-year core cycle correlates with sea level fluctuations and global temperature shifts. For years, we looked to the stars or the atmosphere to explain these rhythms. Now we are looking down. If the core's rotation affects the magnetic field and the planet's wobble, it could be the hidden hand behind long-term climate cycles that we previously thought were random. To put the scale of this in perspective, think about the energy required to move that much mass. The inner core weighs about 100 quintillion tons, one followed by 20 zeros. Stopping it and turning it the other way would require more energy than the entire human race has ever produced. Yet the Earth does this silently every few decades. It is a reminder that we are passengers on a vessel that is far more active and unpredictable than the solid ground suggests. But here is where the mystery takes a darker turn. If the core is currently in a reversal phase, we are heading into a period where the magnetic field might behave in ways we haven't seen in the modern era. The magnetic field is our only shield against solar radiation, keeping our atmosphere from being stripped away by the sun. If the core's shifting rotation messes with the engine that creates this shield, the consequences could be more than just a slightly shorter day. We are talking about the fundamental stability of the environment that allows life to exist. Scientists still can't fully explain why the cycle is 70 years specifically. There is a missing piece of the puzzle, a variable in the math that we haven't identified yet. Some geophysicists, like Miyake Ishii at Harvard, have suggested that the core might have even more layers, like a nesting doll, each with its own physical properties and independent movement. We are trying to understand an engine while it is running, without being able to open the hood. The more we learn, the more we realize that the center of the Earth is a process rather than just a place. It is a dynamic shifting, and occasionally reversing heart that keeps the rest of the planet alive. As the core completes its current turn and begins to move against the rotation of the world above it, it raises a question that geologists are only beginning to whisper about. If the core can stop and reverse, what else is it capable of? The next chapter of this journey takes us to the one place even deeper than the core. The strange, final boundary where the rules of physics as we know them begin to break down. How can the ground beneath your feet be the ultimate definition of solid when you are actually a passenger on a thin, Brittle crust, you trust the foundation of your house and view a mountain as an eternal monument of stone. Yet you are floating atop a churning engine of liquid metal and crystalline fire. Every step you take depends on a delicate balance of forces occurring 900 kilometers down, in a place more alien than the surface of Mars. Geologists once viewed the Earth's core as a static, unchanging anchor at the center of our world. Now, the work of Xiaodong Song has revealed that the heart of our planet is a restless, spinning sphere that does not always move in sync with the crust. It is a world in constant, silent motion. This hidden movement has consequences that reach all the way up to your wristwatch. Because the inner core is a solid ball of iron and nickel floating within a sea of liquid metal, it speeds up or slows down independently of the surface. When that heavy metallic heart shifts its rhythm, it pulls on the rest of the planet. In 2023, researchers at Peking University noted that these shifts are linked to tiny changes in the length of a day. We are talking about fractions of a millisecond, which are intervals of time so small you could never perceive them without an atomic clock. The very definition of a day, the most basic unit of human life, is dictated by the mechanical grinding of a crystal heart we will never see. You might wonder if this internal braking system affects your life in more tangible ways. While the core's rotation won't make you late for work, it is the primary reason your smartphone knows which way is north. The motion of the liquid outer core against the solid inner core acts like a giant electrical generator, creating the magnetic field that shields our atmosphere from solar radiation. Scientists have found that as the inner core's rotation fluctuates, the magnetic field can wobble or drift. This is a practical reality for global navigation. Every few years, agencies like the British Geological Survey update the World Magnetic Model so that the GPS on your phone and the navigation systems in airplanes remain accurate. There is a humbling beauty in the idea that our entire civilization is tethered to a spinning compass needle at the center of the Earth. If you hold a simple magnetic compass in your palm today, that needle is reacting to the movement of iron thousands of miles below your shoes. That movement is currently in a state of flux. A 2023 study in Nature Geoscience suggests we are entering a period where the inner core is slowing down relative to the surface. It is part of a cycle that lasts 70 years, a heartbeat that spans a human lifetime. We are living through a moment where the engine of the world is shifting gears, transitioning from spinning faster than the crust to spinning slower. This discovery turns the Earth from a cold rock into a living machine with moving parts. For decades, researchers like Miyake Ishii have peered into this darkness using the echoes of earthquakes to map the innermost inner core. They found a distinct heart within the heart, a relic from the very beginning of our planet's history. It suggests that the Earth has physical records of how it cooled and solidified over billions of years. When you look at a stone on the ground, you are looking at the cooling skin of a massive furnace that is still very much at work. What does this mean for you as you go about your day? It means that solid ground is a useful illusion. We live on the cooling embers of a planetary collision that happened 4 billion years ago, and the fire is still burning at the center. The fact that the inner core might be pausing or reversing its rotation means the Earth is a dynamic system, constantly recycling energy and maintaining the magnetic shield that allows life to exist. You don't need to do anything differently, but you can choose to see the world with more wonder. The next time you see the sunset, remember that the speed of that sunset is being negotiated by a ball of iron crystal beneath your feet. You can track these changes yourself if you know where to look. While you can't see the core, you can see its shadow in the way we measure time. Organizations like the International Earth Rotation and Reference Systems Service monitor these fluctuations to keep our digital world in sync. If they didn't account for the Earth's internal shifts, our satellite networks would lose their precision. Global financial markets, which rely on nanosecond-accurate timestamps, would fall into chaos. We are all invested in the stability of a place we can never visit. Our technology, our travel, and our very sense of time are all built on top of this spinning mystery. It is rare to find a fact that makes the entire world feel new again. We have mapped the surface of the moon and sent probes to the edge of the solar system. Yet the most mysterious place in the universe might be the one directly beneath your chair. It is a place of impossible pressure where iron becomes as hard as diamond and heat rivals the surface of the sun. It dictates the length of our days and the direction of our journeys. Knowing that this massive sphere is currently slowing down creates a profound sense of scale. It reminds us that we are small, but we are part of something incredibly vast and powerful. As you move through your world today, try to feel the weight of that reality. Every mountain range, every ocean trench, and every city skyline is just a thin decorative layer on a much larger story. We are riding on the back of a giant that is still moving, still changing, and still full of secrets. The Earth is a vibrant, mechanical masterpiece spinning a web of magnetism that keeps us safe in the cold vacuum of space. The core is the pulse of the planet. It is a reminder that even the most permanent-looking things in our lives are part of a much larger, much more ancient cycle of motion. The next time you look at a compass or check the time on your phone, remember the spinning crystal heart 4,000 miles below. It has been turning since long before the first humans walked the earth, and it will continue to turn long after we are gone. We are temporary guests on a world that is never truly still. The ground is the roof of a vast, golden engine that keeps the lights on for the rest of the universe. It is a silent, spinning heart that ensures every morning the sun rises exactly when it should. Subscribe, a new breakdown like this every day.